the angle of sliding or angle of repose. It is the angle that an inclined plane makes with the horizontal when a body placed on it just starts sliding down. Consider an inclined plane OB whose angle of inclination with the horizontal surface OA can be changed in the figure. Suppose a block of weight W is placed on the inclined plane. The weight W will act vertically downwards through the center of the gravity of the block. Increase the angle of inclination very slowly till the block just begins to slide down the plane. This particular value of the angle of inclination is called the angle of sliding or the angle of repose. It is denoted by phi. The value of phi depends upon the material and the nature of the two surfaces in contact. The weight W can be resolved into two rectangular components, W cos phi and W sin phi. The component W cos phi balances the normal reaction R, while the component W sin phi is equal to the limiting friction FMS. Therefore, W sin phi upon W cos phi is equal to FMS upon R, or tan phi is equal to FMS upon R, but FMS upon R is equal to mu s. Therefore, tan phi is equal to mu s. The tangent of the angle of repose is equal to the coefficient of static friction. This fact is used for finding the coefficient of static friction in the laboratory. But mu s is equal to tan theta. Theta is the angle of friction. Tan phi is equal to tan theta, or phi is equal to theta. The angle of repose is equal to the angle of friction. Body sliding down an inclined plane. Consider a block of mass m and weight W resting on an inclined plane OB in the figure. Increase the angle of inclination to alpha such that alpha is greater than the angle of sliding. Let A be the acceleration with which the block begins to slide down the inclined plane. W cos alpha and W sin alpha are the two rectangular components of W. The component W cos alpha balances the normal reaction R. Resultant force, which is parallel to the inclined plane and downwards, is equal to W sin alpha minus Fk, where Fk is the force of kinetic friction.